Hey folks, so some of you asked to make a video on LangGraph. This is something released by LangChain recently where you can make agent applications or different LLM applications. And the concept here is that you can make a graph and call that. So there is a blog post. There are some notebooks provided by the LangChain team. So I would suggest for you to check them out, but wanted to start with something very basic. So the simplest graph you can make is what's shown here. Basically, you have two nodes and an edge that connects them. And then we have the user input that is in form of some sort of query. And then we go through the graph and then we get some output for the user. So the way I like to see nodes is basically something where you can run functions. So you can make a function call here, function call there, and in between that, there is some return value that comes out of this function that basically passes along to the next stage. Just to understand, we have two functions here. Both are simple functions. We basically take a string from the user. In this case, we take hello. And then in our function one, we basically return that string concatenated or attached with another string which is hi. So when it goes through node 1, we have hello hi, and then same thing with node 2, we take the string we have from before and then add something more to it. So now we have hello hi there. This is a very basic application of the graph in this case, and the way this looks in our code. So there is a companion notebook that you can use. There is quite some notes that I tried to add in there. In case if you have any additional questions, feel free to reach out. So the functions that we looked at basically are these here. Function 1, which takes an input, and then it adds hi or a string to that input. Same thing, we take input 2 in our function 2 and then add what we saw before. So the whole thing becomes hello hi there. Okay, so now the fun part. So how do you build a graph or a LangGraph app? So first thing what you do is you're going to import the LangGraph library. So something you can install, pip install LangGraph. And this is a minimal version. You are assigning a workflow and we're using graph in this case. We're also going to cover something else just a few cells down. So now we start with an instance of graph that we're assigning to variable workflow. And to this, we add node 1. So as we saw in our sketch over here, for node 1, we have function 1. Node 2, we add function 2. This could be any function. We're just using something basic here. And then the edge between those, as we saw in this sketch here, that's going to be going from node 1 to node 2. This is important because you start somewhere in the graph, in our case node 1, then we pass some information to node 2, and that's what's happening here. We're going from node 1 to node 2, and then we set an entry point for this graph, and then we set an exit or finish point of this graph. And what happens is when you compile this app, and this notation is something you might want to remember. This is from the LangChain team. Once you compile it, so in our case, let's run the functions and then also let's run the graph. Now we can invoke, as we saw before, where we say hello, and then it goes through the graph. Concatenate string at each level, and this is something helpful I saw in one of the LangChain provided notebooks where it just looks at output at each node level. You can pretty much take as is. So what's happening is from node 1 we're getting hello hi as we saw here, and then it goes through node 2, then we add all of that, and then at the end we have this hello hi there. So at each level we can basically print out what's happening in this graph. Now this is quite simple, right? So just adding some sort of string. How about we make an LLM call? So the goal here would be node 1 will make a call to LLM, and from there it's going to get a response back. And once we get a response back, then we pass along to node 2, and then we do something. And in this case, we'll do something very basic. Again, we just say agent says, and then we just provide what was said by the agent. So Let's keep going over here. What we want to do is we want to install LangChain OpenAI, the package that's available from LangChain team. And something else I've done is I have an environment file, something along this, where I have provided the OpenAI API key. So I would suggest for you to add your API key here, create a .env file, and then you can pretty much call the model. So I'm using python.env package here to load the environment variables, assigning the API key, and then I can call. So we know from our LangChain knowledge that you can pretty much import any of the LLM or chat models and then call them. And in this case, I invoke the model with just a simple string saying, hey there, and it comes back saying, hello, how can I assist you, right? So this is pretty simple. Now we're going to take this content portion just to start with a string. So if we do .invoke and then take the content portion .content, we get the string out of that. Now we just modify our function one. So instead of just attaching or concatenating a string, what we're doing is we're saying we're going to take the input from user, pass it to the model, and the response we get out of that, the content portion, we're going to pass to the next node. And the way we do it is that we have our first node we call agent. This is something that you'll notice that many of these nodes will be called agent, doing different tasks. So we attach or we assign function 1 to agent, node 2 the same, function 2. The only thing it does now is it has this agent says string, and to that we add the string that we get from node 1 or agent node. So again, we have the edge going from the agent to node 2 as before. We can run the cells and get the response. So compile the graph app, and then we say, hey there. Now what happens is it went through the whole graph through the nodes we had, and then we got this saying agent says, and then the text from the LLM. So if we were to see again what's happening at each node level, our agent said, hello, how can I assist you? And then basically took that and added this. And then we have the string at the end, which basically is what we expected from our graph. So now this is quite simple. At least we got started off with how we can build these LangGraph apps, right? So that's the benefit of using a graph structure where you can process at each stage and move on. So in this third case, what we're going to do is we are going to make the LLM call, but then also we have a task for the LLM. We're not just going to say, hey, how are you? We're going to take the city and parse it out of the user query. So in this particular example, if the user were to ask what's the temperature in Vegas, we take this Las Vegas portion out and we only pass that to the next node. And in this node, we're just going to make an API call to open weather map. This is something available in LangChain. It's a tool as well as wrapper. So you can make an API call and set that function separately outside as well. You don't necessarily have to use the LangChain wrapper. But then at the end, the goal is that we get something back to the user saying in Vegas, this is what's happening. Okay, nice. Let's keep going. So what I'm going to do right now is for the function 1, we're going to change this to a different function where we're saying your task is to parse the city name out of that and nothing else, right? And it is based on the input available. And still, input 2, our function still the same. So let's run this. The graph is still the same. Nothing changed here. Compile that. And now, if we ask what's the temperature in Vegas, we get Las Vegas because that was the task we gave to the agent just to parse the city. Okay, nice. We're making some progress. Now, for the next stage, which is to call the API, I'm going to install the package for open weather map. With that, I'm also going to assign the key. So this API key, you can get it from the Open Weather Map website. There's also some documentation available on LangChain website. The only thing I notice is to get this key, you have to register an account. You can do a free account without adding your credit card, but then it takes a few hours to activate the key, you'll get an email. So that was a bit of a process, probably 4 to 5 hours or so just to get the API key. But then if you were to use the LangChain wrapper available for this open weather map, the usual way is you can provide a city name and then it gets you this data right here. Now we want to benefit from that, so we take our previous query or this prompt that we gave to our LLM, and in the function two, now we're changing this weather run. So we're taking what we learned previously from our function up there and then assign that to function two. Okay, nice. Now everything else in how we set up the graph is the same. The only thing I'm doing different in this case is that I'm calling the node 2 as tool. That's what LangChain calls agent and tools. So with that, I'm going to be passing the node 1 info and attaching the edge with node 2, which is tool in this case. Just make sure your naming that you give for node is changed for each of these cases. And once we have that, we're going to compile it. And when we ask question, it's hopefully going to parse the name of the city and pass it. This is what happened. And then again, if we want to see it, what happened at each node level, we see that agent said Vegas, and then our tool took that information, sent it, made the API call, and we got something back. And then we're seeing this whole thing is available to us. So that's the output that we got. Now, the thing that we realize is our user asks only for temperature, but what we get back is the whole weather report for the city, right? So that's something we need to change. And what we know is if we were to make another call to an agent or to LLM application, we can ask for this particular node to take the info and see what was the user's question, and then only respond with the information asked. So we want it to respond that the current temperature in Vegas is this, right? So because that was a question by the user. Okay, so how can we do that? Basically, we add a new node, right? So what we want to do in this case is we have this task provided, and we want to provide the user input. But now the trouble is, since we're only returning one value from here to the node 2, and then from node 2, we're passing just the response of the API to node 3, we don't have the user input that was available to us. So that's something we need to pass along. And something that's made easy in LangGraph is that you can pass some data types across all of the nodes. So you can pretty much pass either a dictionary or an array or any data type where you can make changes. So basically you want to read something off of it, you want to attach some value to it. So a common thing that you'll see in the notebooks provided by LangChain is that they use a dictionary, which is agent state, and within that you'll have something called messages, which is an array. And the way it looks like, if I were to run this, if we have no information or no text available within it, then this is how it looks like. This is the agent state that we're going to be modifying. Basically, we want to take this dictionary, this state, and then either append some values to the array or read something off of it. So in our function 1, since we wanted it to be just the user input, we could have just actually used the user input and not necessarily read off of this state, then whatever was input we can have provided here. But then just to keep things uniform, what we're doing is we're going to pass this particular notation, this dictionary with the messages in there, and we're going to read what's in the messages. And the last element that was in that array is the user input. Since we just started this is for the node 1, we could have just used messages 0 or just whatever element is in there. But just to keep notation same across the functions, we'll use messages and the last message in that array. And basically what we're saying is our previous prompt is the same. Our user input is that last message we saw. And then we provide that to the model. Once we get a response back, we're going to append it to that same array that we're talking about. Same thing in our function 2 as well. We read what was the last element in the array, and then we pass that. So that's going to be Vegas, the city name in this case. We send that over to our model, and then we append it to the same array that we're talking about. Now, the change that we have now is function 3. We said we could use the function 3 here and invoke the model, but then we wanted to pass the user input. So the only thing that we added to it, in addition to how we read the information, we also have the user input available to us, which is the first message in that array. The API information or response we have as the last message in that array. We take both of those and provide that to our agent, saying that your task is to respond back to the user query based on the available information here. And then we can now run this. And what's going to happen is our graph is going to change a bit here. We added this third node as we mentioned before, and then to that node we're basically attaching an edge. So this edge is from tool to the responder, so basically from node 2 to node 3, and then we change our entry and exit point, basically node 1 and node 3 in this case. Let's compile our workflow again, and now if we ask the question, it's important that we ask question in the data structure that we want our application to run with. So if we do that, what's going to happen is it's going to go through all 3 nodes, and then it's going to provide us the information that we wanted. And if we want to look at each stage, what's happening here is at the first node we attached the Las Vegas. This is the response from the LLM. This is the first user input, and then we send it over to the tool. Then tool sends us some response back, which is the third element here. And then in our last node, this is where it reads off the API response, and then it basically gives us this response, that is the current temperature in Vegas is the value available, and that's something we want as a response back. Now, if we wanted, we could have also make it where the response from third node is also something we append to messages, as we did for function 1 and 2, but we kept it where it's just a string that we get back. Now, this is just for understanding. Of course, in our application, we'll make it uniform, so all of it is using some state which is properly passed along the nodes. That brings us to some of the notation you might have seen in the notebooks from LangChain. This state, this agent state, is a certain format. It's a dictionary which contains a list in there. We had to read from it, we had to append something to it to make it easy on ourselves, something we can utilize. It's available from typing. We have a class for agent state, which is a dictionary, and within that we have messages, which is a list or a sequence, and then we say operator.add. Basically, if we were to assign any value to messages, by default it adds it or appends it in that array. That makes it easy for us, so next time when we call this, we'll see something appending to it. Now, other thing is, we realize that if we run this app, if we say something very basic like, hey, how are you? It's not going to run. So as an example, if I were to just run here saying messages, how are you, right? So we're just passing something very simple. We would have expected our app to respond that, but it's not happening. The reason that's not happening is because it's expecting to parse this city name from node 1 and then pass that to node 2, and then the API response back from node 3. But if that's not happening, then our app freaks out. It wants that info. What if there was a way we could make it where only conditionally it looks at the information asked by the user? If it is about the temperature, then it uses that tool. If not, then just respond back to user saying, hey, I'm doing good, how can I help you? The way we can do that is using a conditional edge. That's something available in LangGraph, where essentially what you're saying is, if the question is about the tool usage, then use the tool. If not, then just respond back to the user. So we're going to do a few changes now. It might be quite a bit, so I would suggest for you to follow along and ask if you have any questions. First thing I'm going to do here is use the agent state as a class, as we mentioned earlier. And the second is We know that there are something called tools available in LangChain. This is something you can import. There are many different type of tools available for agent applications. And what you can do is you can bind the tool directly to the model. So in that way, when we make the call to the model, it knows that it has the possibility to use that particular tool. And this is made easy by LangChain, where essentially using this convert to OpenAI function, it converts a tool to something that you can use for OpenAI function, and then you can bind that function to the model call. Now, with both of these, or making both of these changes, what happens is our function one becomes as simple as that. Basically just 2 lines here, and we are good to go to the next function. So it's calling the model based on the user input, and then from there we're going to be returning the response in the same state as we provided it. So in function 2, we're going to change a few things. One is that we have this from before, where we saw that we can read the last message, and in our case it's going to be from the agent or node 1. And then second is we're going to parse the JSON that's available from that particular node. And the reason for that is I'm going to go down a few cells where actually I ran this before. So what happens is our message that we get back from the agent is in this form, where it says the AI message, it has some content, and it has some additional keyword arguments. And within that, the agent lets us know that it does not have that info, so it needs to make that function call. And that function call is going to have which tool are we using, so that name is available to us by the agent because it knows what all tools it has available to it. And then it also provides us arguments in the form that it knows that the tool is going to be using. I'm kind of reading what's available in the additional keyword arguments that's available in the last message, and within that I'm looking at the function call, and within that I'm looking at the arguments, and I'm basically parsing the tool and the argument for that, and I'm passing that info to this tool invocation. Now, tool invocation is something available for us within the LangGraph package. Also, in addition to that is tool executor. So basically what you do is you assign the tool name and the argument it needs, or the input, to tool invocation, and then you invoke the tool using this tool executor. So that's how you can utilize any of the tools. So once we get the response back, we can either pass it as a string, or we can pass it as something called function message. This allows our next node or our agent to know that there was a response back from the tool, opposed to AI message or human message that is also available within LangChain. So once we run this, we get a response back, and this function message, we're going to send it in the same dictionary that we're looking at earlier. So this is the state, and then we have something else. Now, let's say, for example, we are done with our step 1, where user provides input, step 2, step 3. Now we get something back, right? So the response is sent to node 1. We want node 1 to make a decision, right? It needs to know where to go from here. Does it go back to the user? Does it use some other tool? Or what happens from here, right? So this is the function we need to define, where we say if function call is available in our last message, then continue with the function call, make a call for that function or that tool. If not, then end this, right? Just take the information available to you and then just end the discussion over there. So it might be information from one tool, it might be information from multiple tools, essentially where we have everything what we need, and then we just provide that to the user. So now when we actually get to the implementation of the graph, there are a couple of things that you'll notice is different from the other cases. First thing, we imported graph, or what we can do is we can import the state graph, and in this case we have to pass some sort of state to the graph, and we know that we have already assigned agent state, so we can pass agent state from the beginning to the end node of this graph. So this is something available as state graph in the app. If we were to use this graph, then essentially the first message, the input that you're providing, it could be in the format that we want. So for our uniformity, what we did is we pass the message to our graph in this particular format from beginning, but then it didn't have to, as long as there is something that goes into our first node, and then there is some information returned from each node to all the way to the last. We can just use the graph in that case. If you know that you're going to be providing a certain state, a certain data structure that we're going to be passing along, then in that case, you can use this state graph. So since we already have the state assigned, what I'm going to do is I'm just going to comment the old ones, and now we're going to use the state graph. Next is each node gets functions. So functions we saw that we tweaked them a bit earlier. And then once we do that, then from node 1, we have, from the agent, we have an edge which is conditional. This is something available in LangChain where agent can decide if it wants to go here or not. So when we get to the agent, it has the option to decide where to go. And if it decides to continue to the tool, then it can go to the tool. If it decides no, it wants to end, then it can basically end the discussion. And when that happens, in that case, it's going to return to the user, right? And if it goes to the tool, in that case, we have something that happens at the tool level, and we have this edge which returns information back to the agent. So in this case, we're saying that if a tool is called, then the information from tool needs to go back to the agent using this edge. Whereas if there is something that was provided to the agent, it has an option to either use the tool or not to use the tool. So that's the reason that particular edge from the agent to the tool is conditional, this blue one here, but the red one here is something that is going to happen if this is called, then it has to provide some information back. That's the reason we're using this edge in that particular case. We assign the entry point for this as well as the agent, and then what we're going to do is I'm just going to bring in this end, and with that, let's compile the app. Okay, let's go back. Let's make sure we run all the cells. Great, and then we call this as well. Nice. And now we're going to pass the first thing, right? This input, this message. As we saw before in the format it likes, and then it's going to go through the whole thing, and then what it's going to do is, as you notice in this messages, it's going to have the human message, and then that goes on to the node where it processes that human message. It responds back saying that, okay, make a function call. And in that function call, we're going to be calling this tool, which is what we bind to the model. And then from there, we use the function or the tool, and then we get some response back. So now our final call, which is from the agent, it knows that the function call was made. So we have that info available. And then based on all of that conversation previously, it's going to decide the final response to the user, which is the temperature that was asked by the user. Again, we can run this and see all of the steps separately if we want to see that. So hopefully with that, you got an understanding of the usual notation, how the graphs work in LangGraph. And in case if you have any additional questions, feel free to reach out. Will do my best to make additional content around that.